So right now, ladies and gentlemen, please join me in welcoming the President and CEO of Siemens Taiwan, Frank. 让我们一起掌声欢迎台湾西门子总裁暨执行长张和系。Welcome, Frank.
大家早安。
早。
Before I start, let me start with a provocative question. So, will the AI bubble burst? Because a lot of us are asking, is AI truly transformational or is it just a bubble? And there are some warning signs. You all read in the newspaper about the hype. We see the high evaluations of some companies. We also see projects that don't scale in that space. And even tech leaders like Mark Zuckerberg or Sam Altman or Bill Gates, even they acknowledge it. But they also agree that AI is truly transforming the global economy. And the scale is real. So when we look at these statistics, AI investment today is bigger than what it was during the dot-com era, and predicted to even grow and accelerating further. And today, in this year, investments into AI are exceeding $550 billion US dollars. So for us at Siemens, the answer to the question if AI is just a bubble is quite clear. No, it's not a bubble. In fact, it's industrial reality. Today, digital twins powered by AI allow companies already to simulate simultaneously thousands of scenarios to predict problems and to take action before issues become cost. Industrial AI is driving resilience and it's driving sustainability, cutting energy usage, reducing waste, and also accelerating net zero. And this is happening globally and also here in Taiwan. From semiconductor fabs to the energy system, AI is not a bubble. AI is truly a productivity engine. So in the next 20 to 25 minutes, please allow me to walk you quickly through how Siemens is using AI today to deliver real long-term value to our customers and not just a hype. The next 10 years will be another golden decade for Taiwan. Huang Jin Shenyan. Why? Why Taiwan? Because Taiwan has a very proud legacy of world-class manufacturing, which was built up through the last years. And we see all the big players dominating global markets, like, for example, also Foxconn, who have developed out of this. And Taiwan is number one when it comes to build AI servers, build AI infrastructure. And Taiwan has a huge potential to not only build AI systems, but to use AI to become even better because of this very strong industrial base. And of course, Siemens is very proud to be here with our customers in Taiwan and help them along their journey. But the next golden decade won't be possible without industrial AI. Why is that so? If we apply AI from the virtual space in the real world, we cannot afford AI to hallucinate. We cannot allow AI to be mostly accurate because we want AI to optimize our factories, our transportation systems, our electricity grids. There is no room for error. So we need to move AI beyond pure algorithms, and we need to train AI in the real physical world with real data, with real engineering data, in order to make it safe AI. And this is what Siemens is doing with our engineering know-how together with our customers, providing this path to the industrial AI revolution. So, for instance, in order to move industrial AI forward, Siemens and NVIDIA, as you saw in the video just now, we have formed a very strong partnership to build what we call the Industrial AI Operating System. So AI applications stand alone are already there numerous, also in industrial environments. But the real scaling effect you can have when you have an orchestration fabric orchestrating these industrial AI applications to scale them throughout your factory network in your global operations. And this is exactly what Siemens and NVIDIA are doing, because Siemens is bringing decades of engineering know-how, very deep engineering know-how, process know-how to the table, and a lot of data. And NVIDIA is bringing huge computing power and, of course, also an AI layer, CUDA, to the table in order to make that happen. And together we are building what we call the industrial metaverse, allowing companies to simulate any physical process in a virtual environment before putting it into implementation. And in fact, in our electronics manufacturing factory in Erlangen in Germany, we are doing this with NVIDIA together. We are building the first fully AI-controlled factory globally at the moment. So if you happen to be in Germany, drop me a line and I think I can organize maybe for you to have a visit there. As Jensen Huang put it, Siemens is helping NVIDIA and NVIDIA's supply chain to become faster and achieving more with less and delivering quicker. And this, in the end, leads then also these supply chain and NVIDIA to help Siemens delivering these tools in a faster way. So our partner, Foxconn, so we are also having a strong partnership with Foxconn. They are already leveraging this partnership of NVIDIA and Siemens. And Foxconn, and what you see here in the animation, is a digital twin of a Foxconn AI factory, where Foxconn is assembling AI servers. And this is not just a movie with X, Y, Z and cost and time. There is all the engineering data needed to complete the process is in that digital twin. And it's helping Foxconn to not only simulate and optimize the facility when it comes to layout, plumbing system, utilities, but also where you put the machines, how the process flows through the factory, but also it allows Foxconn to train the robots in the digital twin before they are in the real world on the factory floor. It's a huge potential. And avoiding a lot of learnings in the real world, which you can already have in the digital world, saving a lot of money and speeding up also the deployment of these factories. Another example I want to bring to you is also the breakthrough which industrial AI is supporting now when it comes to innovation. So for decades, we are dreaming of having fusion energy, limitless energy. And a lot of money is flowing into that sector recently, and a lot of companies are starting up in that sector because finally now, because of industrial AI, we have the chance to make it happen very quickly. There is a company, it's a spin-off of the MIT in the US called Commonwealth Fusion Systems, and their target is to build a fusion reactor. And they are using Siemens Teamcenter and SimCenter and NX software in order to build a digital twin of this reactor, simulating the complete physical reality in the digital twin, which is helping Commonwealth Fusion Systems to compress years of physical experimentation, which in that sector was normal until recently, into just weeks of simulation in the virtual space. And this is highly complex because here we are simulating really, really complex processes from physics regarding particle containments and magnetic fields. And this is speeding up innovation in that sector. It's not only this company, it's a lot of companies who are pretty much accelerating now into making it happen and hopefully helping us to get limitless power in the near future. Another example I bring to you is very profane, right? It's from the car industry, but really interesting. So BMW is utilizing Siemens's computational fluid dynamics software to simulate airflows so that they don't have to build a wind tunnel and simulate this in a wind tunnel in a real environment, which takes a lot of time. If you change one parameter, you have to change the wind tunnel, and it consumes a lot of time, costs a lot of money. And doing this in a software is really accelerating the development times for cars and making them very, very efficient. So this car, for example, I have the same car in Germany, by the way, is very heavy, very big car, but really, really very efficient. And I was always wondering, how can it be so efficient? And it's because of this optimization which happens in the virtual space, in this digital twin. A very recent example is PepsiCo. So one of the big challenges is to build a digital twin. In fact, I would say that's the bottleneck. Because to build a digital twin, you need your best experts in the company who know the process in the deepest way and who know exactly which data is required from which data point in order to build that virtual representation of the physical world. And that's the bottleneck. So Siemens has developed a software, and this was launched recently at CES in Las Vegas. We call it the Digital Twin Composer, which in fact is docking onto different IT systems in the factory's environment and generating the digital twin automatically. And we did a pilot project here with PepsiCo, and the results are just marvelous. You see the numbers there. So let me start with a number in the center. Pepsi was able to increase the throughput in that factory in the real world by simulating all processes in digital twin by 20%. Now, those of you in manufacturing know that this is a massive number. This is really a lot of money. They were able to reduce the money they spent to build the factory compared to other facilities by 15%. Another huge financial impact, positive. But most importantly, because they were able to simulate the whole facility, including all robots, all movements, all processes in the digital twin, before they implemented it in reality, they were able to recognize more than 90% of potential issues which would have hit them during construction of the facility and during ramping up the facility. And we call this non-conformance costs. So they were really able to avoid a lot of non-conformance costs and also shorten the startup of the production time significantly using this digital twin composer. So when we look at automation, you know, for decades we are preaching about automation. We talk about Industry 4.0, and we have already achieved quite a high level with a lot of branches and sectors globally, a high automation level. There's one disadvantage. Automation works best when you have it in a what we call a greenfield kind of factory, because then you can plan from the scratch, you can optimize the factory from the scratch for maximum yield and maximum output. However, today a lot of factories are already existing, so we need to find a way to do this in a brownfield environment, what we call brownfield environment. And this is the breakthrough now for humanoids. And this is really hitting us fast globally. I think all of you read it in the newspaper, and we have a lot of companies now running trial runs with humanoids, and it's working out. So this is one example I want to tell you. We are doing this also in our factory, which I just mentioned, in Erlangen in Germany, where we did a trial run having a humanoid robot performing logistics tasks in an environment with 30 other AMRs and with humans in the production chain. And this was controlled by a platform we call C-Navigate, ANS+. And the robot for 8 hours, for example, during a day, continuously is taking totes, stacking them somewhere else, bringing totes to an AMR, the AMR drives the tote to a machine, or even taking the tote, giving it to an operator, to a human, giving it to a human, taking it back empty, completely autonomously and in a safe way. And this was a really, also for us, was a big breakthrough, showing that in the end, all of this can work in an integrated way. Now, a lot of people tell me, hey, Frank, this sounds all great. Your slides look super, right? And nice pilot projects. How can I do it? How can I get started? And this is now a little bit more complicated, but I try to boil it down in a very basic concept, okay? So a very basic industrial AI infrastructure overview. What I just described to you comprised of the machine, which is controlled by a PLC, we call that a logical controller, and the digital twin and the AI in the digital twin optimizing. Now, a lot of things are missing actually in between, and this needs to be there. We call this AI infrastructure in order to make it work out. So for example, the machine is creating data. This data needs to be picked up. So your production environment needs to be equipped with sensors, power meters, IoT sensors, connected devices, in order to collect data. This data needs to be transmitted, needs to be transported to the data storage, and this we call connectivity layer. And this cannot be any connectivity, because in an industrial environment, it must be industrial grade connectivity. High reliability, low latency, high availability. And then this data is moved to a data processing and storage layer. Hybrid, you have the server in your factory or partly in the cloud. You have it completely in the cloud. Not a lot of people have that because, of course, you want to keep your data, or completely on-premise. And then you can basically, when you have this, you can use the data from your machine and you can build a digital twin, and then you can use AI to optimize the scenarios in the digital twin. And this gives you a feedback how you can then reset the parameters of the machine in order to bring that optimization result into the real world. But if you already include an integration layer, interfaces, and if you build then applications for that production process, for that specific step, you can then actually feed the optimization result back to the physical layer. And this is what is needed, and this is what we have to have as an infrastructure in order to make that work, what I just showed you in the previous slides. It's very important. And it's not only this physical infrastructure equipment, it is also how you do it. And I also have outlined here a very basic way how we can do it. So first of all, you need to have a real problem, a small one, not a big one, a small one. Choose a small problem. What is the challenge? Discuss it in the team, decide on it. Yes, this is what we want to try as a pilot. Check the data around that problem. How much data you have around that problem? Is that data enough to build a digital twin? For this, you need your experts. Start with a pilot case. Use this one small thing and try to make it work out. This is not only important for the feasibility itself, but also for convincing other stakeholders, because there will be a step coming which is expensive. And you need to convince stakeholders to show them it's working out. Then scale this. And this is what I just showed you. Build the infrastructure and train basically your operations team or your team using it. This is the process, how you can come to this. So the strategy is quite clear. We need to combine the real world and the virtual world in order to achieve more with less, which perfectly fits to the strategy of Taiwan, because in Taiwan there's a scarcity of everything. Water, electricity, land, workforce, talent. But this is also why I said the next golden decade will be here, because you have a unique situation to use, or also pressure to use this technology in Taiwan in order to deal with that. So it's also good for sustainability, of course. If we use less to do more, it's always good for the planet, right? And these are studies which have been done by Boston Consulting Group or by Accenture. So using digital twin and industrial AI technologies combined can reduce 12.8 gigatons of greenhouse gas emissions. And globally, at the moment, we are emitting 60 gigatons. In Taiwan, we are emitting around 280 million tons. Using this, like 30% reduction would mean we can save around 50 million tons in Taiwan, which is, of course, this is the real impact for future generations as well. Now, I just briefly give you a couple of examples here in Taiwan, how this is already deployed. So from manufacturing, in Taichung, we have the big center of machine building, and we have machine builders like Hota or Gotway who are using Siemens technology, AI-powered technology, in order to become better, optimize, and increase their productivity by adaptive control and monitoring systems in the machines, who are automatically recognizing, detecting, and improving the tool usage in the machine, depending on the degradation of the tool. PlayNitride, a big player when it comes to micro-LEDs, is using Siemens SimCenter digital twins in order to simulate the production, mass production of these displays, and they significantly reduce the material waste and accelerate the time to market of these displays. When it comes to buildings, next to the main station in Taipei, there is this new building called the Q Square Mall. A very simple AI application runs in the Q Square Mall from Siemens. It's a AI machine learning tool which is automatically analyzing and manipulating the settings of the Kungjiao, of the chiller system, of the air conditioning, in order to optimize energy usage of the air conditioning. And only in that building, and this is real numbers, we are saving more than 1 million kilowatt hours per year by using this AI algorithm, which is actually also not expensive and very fast to deploy. And if you would imagine we would do only this one in each building in Taiwan, this would be a massive impact. We would not have to build so many new power plants. From energy, another example. So we have what we call Grid Scale X platform, which is actually an AI-powered digital platform to control electrical grids. The electrical grid is the most complex piece of engineering humankind has built. Really complex, really huge, but under a lot of stress. We have renewables coming in, we have electric vehicles coming in, we have increased demand in energy consumption. The electricity consumption globally will triple until 2035 because of the AI boom, because of data center boom. So it is very important not only to build new grids and build new power plants, but also to look into how can we use the existing infrastructure by applying software to achieve more throughput in the grid, to increase the capacity in the grid. And this is what we are doing with that software. So for example, we have one component there, it's called dynamic line rating, where the maximum amount of power allowed through a certain power line is limited usually by a default value, which is based on the hottest weather condition. But most of the time of the year, the weather is colder and we have wind chill, but the line capacity doesn't allow more throughput, although physically it would because of that protection setting. And this AI is analyzing the weather data and is then dynamically resetting the protection settings of the line. And we can achieve like 20% more throughput through the same line, no change in hardware, just by using software. I brought this example because it demonstrates the value of software. Now, how can nations and companies stay competitive in the age of AI? And to sum it up, software is important because software allows scalability. Software can be deployed fast. Software cannot only come alone, needs hardware. I showed you this just now. If we don't have the basic infrastructure in place, we can not move this AI optimization result to the real world. And only then it can have an impact on us and can make the world a better place. So this hardware investment needs to be balanced with software. Partnerships, ecosystems is really important. Nobody can do it alone. Siemens cannot do it alone. NVIDIA cannot do it alone. Google cannot do it alone. The universities can do a lot of research, but you know, what's the impact on the real world? We need to work together. Also, the media is important. Media is very important to find or let's say create consensus in society for certain investments. And of course, we need to be fast. We need to move fast. We need to learn constantly. We need to adapt. It's a very agile process. This is not working if we think about 5 years projects, 7 years projects. We need to be able to slice it up and work in an agile way to deploy, learn, correct, deploy, learn, correct. So the consumer AI makes the headlines, ChatGPT, right? But the industrial AI, as I showed you just now, this one really makes the impact. And deploying this, Taiwan can really look forward to a next golden decade. Thank you very much.
Thank you so much, CEO Frank, for the informative presentation. Please kindly take your seats. 非常谢谢总裁的分享。